It began not with a bang but with a whisper, a faint, almost imperceptible smudge on a digital image captured by a lonely observatory high in the Chilean Andes. At first it was just another data point in an ocean of celestial noise, one of thousands of near-Earth objects catalogued and tracked with dutiful precision. This one, however, was different. It didn't follow the familiar, predictable arcs of its brethren. Its trajectory was a straighter, more menacing line. A young astronomer at a dim console fueled by lukewarm coffee and a passion for the cosmic ballet, ran the calculations again, then a third time. The numbers were stubborn, they refused to change. Not a graceful dance, but an impending collision. The object was given a sterile name, 2025 AU-27, but names fail to capture a rock the size of a small country, hurtling through the vacuum of space at tens of thousands of kilometers per hour. A remnant from the solar system's violent birth, a cosmic wanderer on a collision course with the only home we've ever known. Initial reports were quiet, encrypted channels, space agencies, a verification here, a cross-reference there. Every telescope that could be turned toward that patch of sky was. The giants on Mauna Kea, the powerful eyes of orbiting sentinels. The conclusion was inescapable, a chilling consensus spreading through the scientific world. The news broke on a Wednesday. It wasn't a leak or a sensational headline, it was a coordinated, solemn announcement from every major world leader. The message was translated into every language, broadcast on every screen. Massive digital billboards in Times Square, small battery-powered radios in the Amazon rainforest. For a moment the world fell into a profound silence. Traffic stopped, conversations halted, the relentless hum of human activity paused. 7 billion minds tried to process a single terrifying fact, an asteroid, an impact, a threat to everyone. It was the universe holding up a mirror, a single, vulnerable crew on a tiny spaceship. Then came the fear, a primal, gut-wrenching fear that transcended culture and language. The stock markets plummeted in pure panic, whispers of despair spread. What could our squabbles and our technologies possibly do? The time for secrets was over. The time for humanity to face its greatest test had arrived. In the face of annihilation, borders become lines on a map. Political squabbles and ancient rivalries suddenly seem breathtakingly petty. The first, most critical step was the formation of the Aegis Initiative, a global consortium unlike any in history. It wasn't just another UN committee, it was a complete fusion of the world's space agencies, scientific institutions, and engineering giants. NASA, Roscosmos, ESA, CNSA, JAXA, ISRO, they all became one. Their top minds gathered not as representatives of their countries but as representatives of their planet. The first meeting was not about budgets or political posturing, it was a simple, powerful exchange of all data, all research, all classified knowledge related to rocketry, astrophysics, and planetary defense. This global handshake sent a powerful message to the world. Military budgets were reallocated. Factories that once produced tanks began manufacturing components for a spacecraft that didn't even exist on paper yet. With the world now united, the monumental task began, forging the spear to slay the beast. The Aegis Initiative quickly determined that a single approach was too risky. The mission would be twofold. The primary plan was a kinetic impactor, a massive, high-velocity spacecraft designed to collide with the asteroid. It wouldn't destroy it, but would act like a cosmic billiard ball, nudging the asteroid just enough to alter its course so it would safely miss Earth. Simultaneously, a second, more audacious plan was developed as a backup, the gravity tractor. It would use its own small gravitational field to gently, persistently tug on the asteroid, slowly pulling it off its deadly course. Building two entirely different, incredibly complex systems at the same time was a staggering undertaking, but failure was not an option, so redundancy was paramount. Specialized alloys smelted, guidance systems built in clean rooms, microchips fabricated, and ion propulsion engines assembled, an unprecedented global industrial symphony. Launch sites across the planet, Kazakhstan, Cape Canaveral, Kourou, were prepared. Rockets from different nations were retrofitted to carry the payloads. Every weld, every line of code, every calculation was imbued with the hopes of 7 billion people. The teams worked around the clock, exhausted but focused. The spear being forged was not just made of metal and silicon, it was made of human ingenuity, courage, and an unwavering belief that we could, and must, overcome the cosmic odds. Behind the gleaming metal and complex physics was the true force driving the mission, the human engine. It was a global network of minds, a living supercomputer of unparalleled power. The challenge was not just about building rockets, It was about solving 1,000 smaller, intricate problems simultaneously. From optimizing fuel consumption for a years-long journey to creating autonomous navigation software that could make split-second corrections millions of kilometers from home, every detail mattered. The Aegis initiative created a centralized, open-access database where every problem, no matter how small, was posted, and from every corner of the planet, solutions began to pour in. A retired mathematician in Nigeria developed a more efficient algorithm for calculating gravitational drift. A team of game developers in South Korea applied their physics expertise to create more accurate impact simulations. Their work helped refine the target point for the kinetic impactor. This was crowdsourcing on a planetary scale. The spirit of competition was channeled into a race to solve problems, not to beat rivals. To support the teams, a global network of counselors was established. School children from around the world sent in drawings of the hero spacecraft. Musicians composed anthems for the mission. In every city at a set time each day, people would pause for a moment of solidarity, a silent transmission of hope and gratitude. People volunteered in any way they could, donating computing power, organizing support groups, and reminding the teams they were not working in isolation. In the face of a common enemy from the stars, the things that once divided us began to look, well, different. Our diverse cultures, beliefs, and worldviews were revealed as a vast repository of strength. The challenge was not just technical, it was a real test of the human spirit. We needed every perspective. Philosophers and ethicists convened to discuss the profound implications of the mission, making sure our actions were guided by a shared moral compass. Religious leaders from every faith set aside theological differences to offer a unified message of hope, courage, and unity. They called for prayers, meditations, and moments of reflection, not directed at any single deity, but toward the shared human spirit and the success of the mission. Art and culture became a universal language of hope. Artists painted murals, filmmakers created documentaries, poets wrote verses that captured fear, resolve, and the beauty of our united world. This global outpouring of creativity was a vital way for people to process emotions and to feel connected to the grand effort. The mission was given a human face, a narrative that everyone could understand and feel a part of. Even our different approaches to problem-solving became a strategic advantage. The diversity that had often been a source of misunderstanding became our greatest asset. We were a mosaic, not a monolith. The asteroid forced us to see our differences as different tools in a shared toolbox, all necessary to fix the one home we all shared. The day of the launch was a global event. On every continent, people gathered in public squares, in their homes, and in community centers to watch. As the countdowns began, English, Russian, Mandarin, and French, a hush fell over the planet. The launches were flawless. Twin pillars of fire lifted the hopes of the world into the sky. They carried the kinetic impactor and the gravity tractor on their long journey into the void. For months, the two spacecraft flew silently toward their rendezvous with destiny. On Earth, Mission Control remained a 24/7 hub of intense focus. Engineers, scientists, and navigators from dozens of countries worked in seamless shifts, their shared language, the universal tongue of mathematics and physics. A solar flare threatened communications, forcing engineers to create software patches on the fly. A micrometeoroid damaged a solar array, requiring a daring remote recalibration. Problems were met with calm collaboration. A problem identified in Bangalore would be solved in Darmstadt using data from Australia. There was no blame, only solutions. The kinetic impactor, now a silent missile homing in on its target, streamed back its final images. The asteroid, 2025 AU-27, filled the screen. It was no longer an abstract speck of light, but a terrifying, tangible reality. A chaotic landscape of craters, boulders, and jagged edges. The final seconds were counted down not by a machine, but by the lead mission director. 5, 4, 3, 2, 1, impact. Telescopes on Earth and the nearby gravity tractor confirmed it. The impact was a success. A new cloud of dust and debris bloomed, and its trajectory began to shift. The initial data was promising. The spear had struck true. For the next few weeks it performed its slow gravitational waltz, flying in perfect formation with the wounded asteroid, tracking the new path and feeding data back to Earth. The world's best minds analyzed every number, confirming that the nudge from the impactor was enough. The gravity tractor's presence became a guarantee the asteroid would stay on its new, harmless path. The push had worked. Earth was safe. The celebration was global and profound. It wasn't the victory of one nation, it was the victory of humanity over oblivion. We had stared into the face of a cosmic threat that should have destroyed us, and through sheer force of will, intellect, and cooperation, we had pushed it aside. In the dawn that followed, the world felt new. The asteroid, now a fading point of light on a safe trajectory, left behind a lesson etched into the heart of our civilization. The global infrastructure of cooperation, the Aegis Initiative, was not dismantled. How could it be? We had proven that working together, we could achieve the impossible. The spirit of the Aegis Initiative was turned toward other great challenges: climate change, poverty, disease. These were our new asteroids. The same open-source collaboration, the same reallocation of resources, the same sense of shared purpose was brought to bear on long-standing global problems.